Hello everyone. So now I will talk about chapter 13, which is about the kinetics of a particle. We will consider the force and the acceleration. The objectives are we will essentially find the equation of motion for an object, and then we will build a free body diagram of an object. These are the two main objectives for this chapter. So if you look for the foundations of the chapter, that's the equations of motion and the free body diagram. There is a simple question here that asks for the forces acting on a car that moves in a horizontal direction and tries to accelerate. And the first thing is that we have a drag force, which is, the resistance of air, you can say. And then that drag force, since it is the resistance, it should act opposite to the motion of the car. And then we have the friction force, that the friction force is also acting in the opposite direction. And then we have the gravitational force. That gravitational force, let's say that the center of gravity of car is somewhere around here. This is just an approximation. And then we have the gravitational force. As you can see, the two of the forces are acting in x direction, the horizontal plane. And the last force, that is the force due to gravitational acceleration, is in the vertical direction. Okay. What does it mean is that this vertical direction force doesn't have any effect on the horizontal acceleration of the car. And this is actually a simple free body diagram. Okay, that's what we do here. And then now time to consider the word kinetics. Okay, kinetics means that we are considering the forces. The forces are included in the system to look for their effects. Let me just add it here. Yes. So analyze forces in a free body. So we analyze the forces in a free body diagram to see their effect. What is the effect of the force? And that is just the motion. Okay, so let's look at a simple example. The object moves, it has certain velocity. But if I look at the object, I can give you some variables. Yes, say that the example, the object has velocity of 60 mph, and then I say that after 1 hour, what's the distance traveled by the object? It is a very simple question, which is 60 miles. So for this one, you did not need, no need to know what is the drag force, no need to know what's the gravitational force, no need to know what is the frictional force, and then so no need, okay, because that is given information is enough, and that is what we call as the kinematics. Okay, but if I look for the kinetics, then if kinetics then I will say that this is the object, and then some forces are acting on it. He said that we have the drag force, as I said, we have the friction force. Okay, and then there is the acceleration of the car. Say that the ma in x direction. Okay, and then the question comes, so for given values of f, find the acceleration, the velocity, and this distance. in x direction. Then after 1 hour, you see the composition of the problem. In the first case, I don't need anything about the force because I have whatever I need as a result of the interaction of the force. Okay, but in the second case, I have the forces and I'm trying to find what is the result of these forces. And then I can find the acceleration, I can find the velocity, I can find the distance, because the forces, the main cause, are given. So you can say that the causes are given. Okay, and then so let me use another color here. So we are saying that they find the effect. Okay, and then here the effect is given. Okay, that is what the difference between kinetics and kinematics is. Okay, so the Newton's second law. So this is the basis of kinetics. Sorry. So if somebody asks you what is kinetics, if you don't know anything about kinetics, if you don't want, just say the Newton's second law. That will explain. Okay, and then now let's look for it. Say that I have an object and there is a force acting on it. Say that this is force 1 and there's another force which is force 2. I will show them as a vector quantity. And there is another force here, force 3, and then one more, force 4. Okay, and then as a result of forces, so A, so let me just, we may have acceleration. So it is not, so this is very important, that we may have the acceleration. It's possible that there is no acceleration, but we have a net result of the forces as 0. So therefore I can write this one as the net result of forces is equal to the acceleration as a vector. This is the vector equation. Or you can say that the forces in x direction will be max, the forces in y direction will be may, and then forces in z direction will be maz. And that's the scalar form. Okay, this is the, this is whole kinetics. Okay, so this is the scalar form of this vector equation. This is the whole kinetics that we will talk about. Okay, with this introduction, I will start to solve a problem in the next recording. Thank you.